At the end of this video, you'll be able to solve any question on relative atomic mass. This is one of the hardest questions you see out there, but I'll make it so easy that when you see any relative atomic mass question, you want to jump on it. So basically, they say an element X with atomic number 29 has two isotopes. So the isotopes of X are what? Y, let's write Y on the side, and Z. So isotopes Y and Z have 34 and 38 newtons. So already know that since the atomic number is 29, that means they both have the same atomic number. Remember what isotopes are. You see they have the same atomic number but different mass number. So the atomic number here is 29, here is 29. But how do you get the mass number now? Remember that what your mass number A is equal to what your atomic number Z plus your number of newtons. So therefore, what is my atomic number? 29. And what is my number of newtons for Y? You say it is what? 34. So plus 34. Therefore, my mass number for Y will be what? This will give me 63. So we'll come here and write what? 63. Then the same thing for this. We'll do 29 plus 38, which is equal to what? 67. So our mass number is what? 67. So now they're asking us, they now give us the what? The relative atomic mass. Therefore, they now give us X in black. They told us that X is what? Is 2963.5. So this is the relative atomic mass. So these two guys contributed to give you what you are seeing. That is what it means. So now they're asking what is the abundance of this? What is the abundance of Y and what is the abundance of Z? But we don't know, so let's find out. So next what we want to do is give the abundance. Let's say let the percentage abundance of Y be small letter y. So let the percentage abundance of Y be small letter y, and percentage abundance of Z be what? Small letter Z. But remember that since it's percentage, their sum must give you what? 100%, right? Therefore, we can now say that therefore your Z, small z plus y is equal to what? 100%. So you can therefore say your y is equal to what? 100 minus z. So this is the percentage of abundance of what? Your y. So therefore, what I'm going to do now, we will then solve using this. So remember that I gave you the formula. The formula is the percentage of abundance of that element times the mass number of that element. So in this case, y will now become 100 minus z percent times what? Times, remember 100 minus z is what? Is y. So we'll now come here and look what is our y. Our y is 63. So we'll now write it times 63 plus what? Our z plus our z percent times what? 67. Remember that our z, the mass number for our z is what? 67.
then now put it in brackets, is equal to what? Our relative atomic mass. And what is our relative atomic mass? Our relative atomic mass is 63.5. Are you there? So let's solve. So now 100 minus z all over 100 times 63 plus z over 100 times 67 is equal to what? 63.5. So what that leaves us with, we have 63 into bracket what? 100 minus z all over 100 plus what? 67z all over what? 100 is equal to 63.5. So since they both have the same denominator, what do? We say, open up that bracket, we have 6300, that is 6300 minus 63z all over, so then plus 67z all over what? All over 100, because they are both the same denominator, is equal to what? 63.5. So from here we cross multiply. So we now have what? 6,300 minus 63 plus 67 is what? It's simply as saying 67 minus 63. So 67 minus 63 is what? Is plus 4. So we are left with plus 4z. Are you there? So plus 4z is equal to what? 100 times 63.5, that will give us 6350. So 4z is equal to what? 6350 minus, if we carry 6,300 here, now minus 6,300. So 4z is equal to what? 50. So divide both sides by 50, by 4. What do we get? That is 12.5. So z is equal to 12.5. That is the percentage of abundance of z is what? For 12.5. So recall that y is equal to what? 100 minus z. Therefore, your y is equal to what? 100 minus 12.5, which is equal to what? 87.5%. So if it's your jam, you are already done, you just pick your option. But if it's WAEC, you can add and say, therefore, the percentage abundance of, therefore, the percentage abundance, write that percentage in full though. So the percentage abundance of y is 87.5%, and the percentage abundance of z is 12.5%. So with that, we are done with anything related to atomic mass. If you can grasp this, you will be able to answer any other question on relative atomic mass. Thank you very much. See you in the next video or the next lesson.